Hi, I'm Eirinn Rusbridge from NFU Energy. I'm here with Tim Miller from EBRI at the Pyrolysis demonstration site owned by Aston University. So Tim, tell me a little bit about pyrolysis.
Well, pyrolysis is a process in which we're able to take residues and waste from agricultural processes, materials from farms. We're able to put it through a heated chamber without oxygen. We put it through the chamber, it can't burn because there's no oxygen. Out of that process comes a material called char, called biochar, and that has a lot of opportunities. There are a lot of opportunities with biochar for use within increasing opportunities for potential for plant growth. We also get a lot of other materials from it. One is an oily type material, a water-based liquid, and also fuel gas. So we can use this process to both produce something which helps plant grow, but also will produce heat and energy for farms.
Okay, that's really interesting. Can you tell me a bit more about the input fuel that you use?
Okay, so we use feedstocks rather than fuel to go into the process, and these feedstocks can be usually dry, woody-based material, or stalks, or husks, or shells. What you put in has a big influence on what comes out. So if you want to produce a char which is very good, say, for growing, you use certain sorts of material. If you wanted to use the char for perhaps a higher value application, such as filtration, you might use something which is maybe a nutshell, which has lots and lots of pores in it which you clear.
Okay, but in principle, you can use residues or wastes or... Yes,
you can use most things, and it's a combination of balancing what goes in, what the process conditions are, and that gives a guide to what comes out.
Okay. Is there much of a market at the moment for biochar? What sort of values does it hold?
The values of biochar really vary quite significantly because, again, this relates to the value or the material that you put in. So if you put in a material which has maybe got some contaminants in it, you're not going to be able to use that in farmland because you're not going to be wanting to take those sorts of risks. You've got to meet the standards. So under those conditions, you might be able to use that biochar in things like road construction, in which case you get a lower value. If you get a higher value, then if you want a higher value, then you need cleaner input.
Well, that makes sense. So what about some of the other outputs, the oils and the gas? What are they used for?
Well, we've been working with the oily material to actually convert it into an oil which can be used in boilers and also simple engines. And this is useful because it's something that you can take away and you can use when you need to use it. The gases that we produce, they can be used as fuel gases. And you have an option of producing a lot of gas-type material and a lot of heat, so producing high-quality heat and steam, or alternatively producing a more modest amount, but then having, again, a greater flexibility in terms of the equipment you use to process it.
Okay. So in terms of the sustainability criteria, net zero is a very big talking point at the moment. How does pyrolysis fit into that picture?
Well, we've been through a comprehensive process of looking at all of the equipment which is used to produce these materials, doing a big audit on it, looking at how much carbon is used in the steel, the concrete, all the components of these pieces of equipment, along with all the carbon costs of running it. And once we've done that calculation, we come to a very, very beneficial figure, which can be used to significantly counterbalance other carbon usage on farms or in industry. So it's about both being able to put the carbon back in a stable form into the soil, and it's also about replacing the fossil fuels that we might use for heating or for other purposes.
Excellent. And I guess the last question that I've got is, what is the minimum size to be commercially ready to implant straight onto a farm?
Well, we're looking at a unit which would be at least around a tonne an hour. So you need a reasonable amount of feedstock to go into that process. Yeah. And you also then produce a fair amount of material. So 1 tonne an hour is the sort of volumes that people are looking at the moment.
Brilliant. Thank you very much.
Okay, thank you.